explaining about the structure of the atom. Okay, now it's necessary to study about the structure of atom as it is a part of science and we use it in our daily life. Any element with you or beside you, like example pen, paper, pencil, book, chair, all when we try to break them all into small tiny particles, they go and end up in some piece that which cannot be broken. Like that the particle which cannot be broken, it's called as an atom. Like I can take example of Modichur laddu. Everybody will love the Modichur laddu. Like when you take a laddu and if you crush it in your hands, you all will be having a small particle or a small pellet in your hand which cannot be broken. Okay, that which cannot be broken, it's called as an atom. Like example, even our body is made up of, like atoms, our body is made up of cells. Like cells contains a plasma membrane, vascular bundles, peptides, and so on. As a small cells which build our body, which build a huge body, right? Which build a huge body. Even our body consists of some atoms such as hydrogen, carbon, oxygen, nitrogen, calcium, and phosphorus. A cell in our body having a structure, even the atom also has a structure as it is like this. It consists of protons, it consists of neutrons, and it consists of electrons. Protons and neutrons are located at the center of the nucleus, and electrons keep on revolving around the nucleus. Then coming to the main topic of the video, how cell goes on dividing and makes a body. Even atoms make a matter. Atoms are the building blocks of the matter. Okay? Atoms are the building blocks of the matter. This positive charge which have we known as a proton, this negative charge is known as a electron, and this no charge, it is called as a neutron. Matter. Coming to the topic of the matter is nothing but anything that has a mass and takes up space. Like I can give an example of pen. Okay, this pen, I will think this pen is a matter. If this pen is a matter, it needs some space to occupy that. I can, if I want to keep this pen, this need this much of space, which I'm holding this pen, this need this much of space, right? And this space is nothing but a volume, and it has some mass, it has some value, it has some volume, okay, inside this. So that is nothing but a matter. Example here which I have given is a brick has a mass and takes up a space. A desk which we use in the classrooms, it also needs some space, right? A pencil which we are using, and air that we breathe, intake, exhale, that also needs a space. Mainly coming to the structure of the atom. Here, atom center. What is atom? We know the atom, right? Atom. What that atom is made up of? Atom is made up of, the central part of the atom is nucleus. Protons and neutrons are grouped together to form a center of the nucleus. Matter is having a atom. Atom consists of what? Nucleus. In that nucleus we are having protons and neutrons, and electrons revolve around the nucleus in an orbit. Now coming to the neutrons which have no charge. I can say for N for neutrons, N for neutral, and N for no charge. Neutron particles have no electric charge, help make up nucleus of the atom, contribute to the atomic mass. Coming to the proton, protons are identified as a positive charge in the atom. Protons are positively charged, helps make up nucleus of the atom, helps to identify the atom equal to the atomic number. For example, H in the periodic table, its atomic number is 1 if this atomic number is 1. Okay, 1. And the number of protons of hydrogen is also 1. Then coming to the electrons. Electrons are negatively charged, found outside the nucleus, which revolve around the nucleus rapidly. And these move rapidly around the nucleus, the electron cloud. And this is equal to the number of protons. Proton is equal to the number of electrons, and electrons are equal to the number of protons. Coming to these, what are these? Dalton, Thomson, Rutherford, Bohr. These are the models of atom in which these models have been given to the scientist's name. Okay, here there are the 4 scientists who invented the structures of atom from starting to ending. Firstly, Dalton, J.J. Thomson, Rutherford model, and Bohr's model. Coming to the Dalton, Billiard ball model means he said that atom is in a ball. Atom is in a ball shape. Like we use footballs, right? Footballs, volleyballs. How the ball shape will be? It will be in a round shape. Dalton said that atom is in a ball shape. It consists of electrons, protons, which the atom cannot be dividable, nor created, nor be destroyed. Coming to the J.J. Thomson. J.J. Thomson, he is a scientist who got a Nobel Prize for inventing cathode rays from the electrodes, such as positive charge and negative charge. And he said that the atom which consists of electrons and protons are plum pudding model. Plum pudding model means he took an example of a watermelon. Watermelon will be in spherical shape. When we take a small piece of it, we get we see there's some black seeds like tarbooj seeds, watermelon seeds. Like that, he discovered protons and electrons. Coming to the Rutherford model, he said that atom look like a solar system. The sun which is present in a solar system, it's a nucleus, and electron is like a planet which is revolving around the sun rapidly. rapidly, but he could not discuss about the stability. So now, as Bohr said, electrons keep on revolving around the nucleus very rapidly. Electrons can neither gain energy nor lose energy. They keep on be rotating. If the electrons are nearer to the energy level, they're having more energy. If the electron is in the excited state, then it is having the maximum energy level. Then this is the whole structure of electrons. Okay, protons which having protons which are having positive charge, neutrons of no charge 0, and electrons which revolve around the nucleus. So this is a whole structure. Okay, these are the protons, these are the neutrons, these are the electrons which revolve around the nucleus. Coming to the small recap of what we have studied further. What makes atoms? What makes up atoms? I said you all that atoms are made up of proton, electron, and neutron. Protons are having positive charge, electrons are negative charge, neutrons are having no charge. And here, all atoms have a same structure. Every atom, whichever atom, pen, chalk piece, ball, anything you take, the structure of atom is same. What is the structure of atom? Spherical. Okay. Here it's a neutron, electron, and proton. Neutron and proton are present inside the nucleus, which are the center of the nucleus, and electron keeps on revolving. Here I have asked the question, why electrons revolve? Why electrons revolve? I'll say why electrons revolve around the nucleus. So protons are having positive charge, electrons are having negative charge. So by using electrostatic force, these repel each other. So proton is in the center and electron keeps on rotating it. If positive charge, they repel each other. They repel each other. Okay? They repel each other. If positive and negative charge, they attract each other. Coming, now I have given here the example of hydrogen atom. An atom, by saying here, an atom is a neutral particle. I'll explain how. What is the atomic number of hydrogen in the when you go and open the periodic table, that will get the 1. So same as the atomic number, even the proton number also will be having a change. Same, and here in hydrogen, electron is also 1. So what is proton is having? Proton have positive charge and electron have negative charge. Here I have given here proton plus 1, electron minus 1. Plus minus, what is it? 0. So an atom is a neutral particle. Number of protons is equals to number of electrons. Now I have given here second example to show here is, it's a helium atom. The atomic number of helium is 2. So number of protons here is 2. Proton is having positive charge and number of electrons also 2, negative charge. As we having 2 protons, right, we'll be having 1 plus charge, 1 plus charge. Okay, these repel each other. So to stop this repulsion, we have invented nucleus between them, which makes stability and which does not make the structure of the helium disturbed. So then the electrons, 2 electrons which are there, these keep on revolving around it. For this I can say this example is plastic insulation. Plastic insulation is inside our house will be having currents be connected to fans, fridges, TVs, etc. Those when we open them, we'll be having the wires which are insulated by the plastic tubes. Okay, that for security purpose. Only if wire and wire, if we collide or if we keep, what it will cause? It will cause a current shocks. Some people may get die. So to avoid those, they have used this plastic insulations. Coming to the energy level, this energy level was explained by the Bohr, in which electrons revolve. When the electron is nearer to the energy level, it's having a less energy. When the electron jumps to the higher energy level, it's having the maximum energy. Okay, the electron jumps towards down, less energy. The electron jumps to higher energy, it's having a more charge. Like this, the energy levels are also called as a shells. They are named as K, L, M, N, O, P, Q. Coming to the firstly, this Bohr atomic model, this is known by spin quantum number, where S is equals to 2n square. In place of n, again 1, 2, 3, 4. Okay, if we keep on adding in place of n, I'll give one example. For K shell, n is equals to 1. 2 into 1 square. What is this? 1 into 2, 1. 2 ones are 2. So this energy level is 2. Thank you.